What's up, guys? My name is Caitlin, and today we're going to be focusing on drawing Lewis structures. So let's start with an ionically bonded molecule such as sodium chloride. Classic, right? So let's start by asking ourselves, how many valence electrons does sodium have? Well, sodium has one valence electron, and I'm going to represent that electron by placing one dot above sodium. What about chlorine? How many valence electrons does chlorine have? Chlorine has 7 valence electrons, so I'm going to draw 7 dots around chlorine to represent its valence electrons. Now, with each atom, each one wants to obtain its octet, which basically means that it has an outermost shell of 8 electrons, or 8 valence electrons. Valence just meaning outermost available electrons. So when these two atoms get close to one another, we get something called electron transfer, which is where sodium is actually going to donate its electron to chlorine. And in doing so, chlorine is going to gain 1 electron, giving it a complete octet, or 8 valence electrons. Sodium actually has valence electrons, 8 of them, underneath this shell, but we don't represent it in this model. So what we end up getting is sodium, and because it has lost 1 electron, it's losing negativity, it's becoming more positive, it's going to gain a +1 charge. Chlorine, on the other hand, has gained an electron, it has gained negativity, so it's going to end up having a -1 charge. And this is how we can represent sodium chloride. Now, one of my favorite things to do is drawing Lewis structures for covalently bonded molecules. And one of my favorites being carbon dioxide, which is something you're probably familiar with. Now, how I start by drawing Lewis structures for covalently bonded molecules is by selecting a central atom in my drawing, and it's usually going to be the atom that you have the least of, which in this case is going to be carbon, because we have 1 carbon and 2 oxygens. So I'll make my central atom carbon, and draw my oxygens around my carbon. Now I'm going to ask myself, how many valence electrons does carbon have? Carbon has 4, and we have 1 carbon according to our chemical formula. Oxygen, on the other hand, has 6, and this time we have 2 of them. So I'm going to multiply this by 2. Now I'm going to add up my valence electrons. So 6 times 2 is 12. Plus the 4 is going to be 16 valence electrons. Now that's how many electrons we have to spend in creating this total Lewis structure. So now we selected our central atom, drew all our atoms on there. Next thing we're going to do is attach them using our valence electrons. So if I make single bonds between all of my atoms, I spend 1, 2, 3, 4 electrons, bringing me down to 12, because each single bond represents 2 electrons. The next thing I'm going to do, since all of them are attached, is try to fulfill their octet rule, giving them access to 8 electrons total. So I'm just going to pick the rightmost oxygen and give it 6 more electrons so that it has access to 8. Now I have 6 more to spend, and if I do the same thing to the other oxygen, I spend all of my electrons. Now we have a problem because both of our oxygens, while they both have access to 8 electrons, carbon doesn't. Poor carbon. Carbon only has 1, 2, 3, 4. So what happens? Does carbon break its octet rule? No. We have to adjust our drawing. I know, not as exciting, but that's where we're going. So here's the key. I'm going to take 2 of my electrons here and turn them into another bond, making this a double bond. And if I do the same thing to the other side, now you'll notice that oxygen has access to 1, 2, 3, 4, 5, 6, 7, 8 electrons. Same is true for our rightmost oxygen. And now carbon has access to 1, 2, 3, 4, 5, 6, 7, 8 electrons. All of our octets are complete. We've spent all our valence electrons, and this drawing is good to go. Thank you guys so much for watching. I hope you have a good one.